All right, so what do we fill in here? All right, I'm gonna just do a couple of these slots as an example. Start with my personal second favorite, which is the heating and cooling curve section. If you haven't noticed, I like math, so the heating and cooling curves is kind of right up my alley. So what I'm going to do here, I need to select a pen first. That would help. And I'm going to go with my favorite color. All right, so heating and cooling curves, they look like this, right? So already I'm starting with a sketch, not words. And so we'll show the solid phase heating, then melting, then that liquid phase warming up, then boiling, and then the gas phase warming up. And I'm going to annotate this, right? That's higher, oops, I do need to say that this is temperature and this is heat added. That higher temperature is the boiling point. The lower temperature horizontal plateau is the melting point. We've got solid here, we've got solid transitioning to liquid, we have just liquid here, we have liquid transitioning to gas, and then we have gas up here. On the sloped portions, Q will be given by the amount of stuff you are heating times the heat capacity times the change in temperature. Remember that that delta T is just for that line segment. So let's even make a note of that. This is for single line segment. Yeah, I don't always write very well with these tablets. All right, so that delta T is from just that single line segment. One of the most common mistakes I see is that people will use delta T as their absolute beginning temperature and absolute ending temperature for the entire problem. If more than one line segment is involved, delta T that's not going to be the right number for delta T. You want delta T to be just the change in temperature for that single sloped line segment. For the horizontal line segments, Q is going to be equal to the amount of stuff you have times the delta H of that phase transition. So it's delta H of fusion for the lower temperature, delta H of vaporization for the higher temperature. And if you've got more than one line segment involved in your particular problem, you're going to have to add up the different line segments. So your Q total might be Q1 plus Q2 plus Q3. Now, if I was doing this on paper, I would be writing a lot smaller, I think, and I would have a lot more space to cram stuff in here. So I'm going to use the margin area over here and add a couple other notes. Units, right? You've got to watch out for your units on heating and cooling curves very closely, because the heating and cooling curves, it's standard for the delta H's to be kilojoules and for the heat capacities to be in joules. It's also standard for the heat capacities to be joules per gram, whereas the delta H's are kilojoules per mole. And so you just have to make sure that for each piece of your calculation, all the units are compatible. If you're doing a single line segment, make sure that the amount is compatible with your constant, and then when you're adding multiple line segments together, make sure that it's either all joules or all kilojoules. If I were doing this on a test, I would pick joules or kilojoules depending on what units the answers are given in. All right, so that is one section of this. I was going to try to keep this video really short, but I think it's going to spill over. Anyway, I'm just looking at the time as I'm recording here. Let me do one more section here on this side of the graphic organizer. That's the solids and unit cells. And this is actually my favorite section in this chapter. It is the closest to the research that I did as a PhD student of anything that we do in Gen Chem 2. So I always really like looking at the unit cells and crystal structures. What did we do? We found the empirical formula based on the atoms that are present in the unit cell. So our interest is on the empirical formula. And in Gen Chem 1, we learned that empirical formulas have the smallest whole number ratios for the subscripts. So if you need to reduce your subscripts by dividing through by the same small number, go for it. You've got to reduce to the smallest whole number ratio subscripts. With our unit cells, I'm going to just attempt to sketch what a unit cell looks like just as a visual reminder. My unit cell sketches are a little sketchy. All right, so something like this, and we'll have different types of atoms like corner, face center, body center, edge. So trying to illustrate some of those different positions. That's an edge atom. You can have a face atom, which is right there, and that blob in the middle is trying to show something in the center of the front face of that cube. And then we also have corner atoms and anything that's not completely inside of the cell. Any atom that is not completely inside of the cell will be shared with other cells. And so we have a calculation that we'll need to do. So as we look at the type of atom, we can have corners, we can have edge, we can have face, and we can have body. And then each one of those, a fraction of it occupies a single unit cell. The corner atoms, it's 1/8 because they're shared by 8 unit cells as the unit cells stack to build your extended solid. The edge atoms are shared by 4 unit cells, so their fraction's 1/4. Face atoms are shared by 2, so the fraction is 1/2. And then body atoms are ones that are completely inside of the unit cell, so their fraction is 1. And then if you're going to figure out how many atoms of each unit cell are, or of each, well, try that again, how many atoms of each element are inside of a unit cell, you count the number of atoms in that position and multiply it times the fraction. So for instance, if you have 8 corner atoms, you would take 8 times 1/8, which means that they contribute 1 to the unit cell. All right. Everybody's version of this sheet is going to look just a little different because you're going to put the things on here that fit best with your prior knowledge, or maybe the things that you did not have any prior knowledge about, right? So everybody's version here is going to look a little different. This is just what I would do for these 2 pieces.